Hello everyone, welcome back to this Siemens S120 PLC and SINAMICS S120 server drive series video. This is our number 10 topic. How can we use MC GearIn, this gear synchronization control, to control the master and slave access? When we use the standard PLC, we can use MC GearIn to implement the velocity gear or synchronization control. Basic idea, you can set the ratio nominator that represent the slave ratio and the ratio denominator. The denominator ratio represent the master ratio. So you can control two or more axes, their velocity ratio relationship. As we know, the velocity gear or this ratio control, this is very simple to control axis velocity synchronization. For more advanced synchronization control, for example, the positioning synchronization or CAM, the more complex positioning relationship, you could use the technology CPU, basically Siemens called S120T CPU. In this video, we will discuss this simple application. I will use standard PLC to show how can we use this MC GearIn. When we trigger master-slave SQ, then you will see the slave will try to catch the ratioed velocity to gear in with the master velocity. Okay, let's shift to the TI portal side and let's see how can we use this MC GearIn function block. As we just discussed, before you implement the GearIn function, you need to identify which kind of GearIn you need to implement. The velocity only or positioning GearIn. So if you only need to do the velocity GearIn, the ratio velocity control, the standard PLC, standard 1500 PLC, that's enough. However, if you have to do the positioning GearIn or CAM, you have to select the technology controller, technology TCPU. Using the different CPU, you will find the different function block availability from this catalog. Like here, at the left side, I'm using standard PLC now. For the synchronized motion, the only function it can do, that is the MC GearIn. This is relative. It can do the velocity gear synchronized function. If your CPU, that's the T CPU, technology CPU. So when you create a synchronized access, and then from the slave access, type of the connection here, you can select the set point and the actual value here. This is very important, especially if you are going to do the GearIn position. So for example, now also if we go to the program, because we are using the T CPU here, then if go to your instruction list, motion control, the synchronized motion, here we can see for this technology CPU, you can pick everything. And especially for this GearIn, if you are going to do the positioning GearIn, so you can use this. Or if you are going to use the MC CAM in, so you can use the CAM in. As we can see here, when we use the technology CPU, we can use the multiple and the more complex function block and the motion control functions. For example, the CAM or positioning synchronization control. But in this video, I'm going to use the standard PLC and we will do the very simple GearIn velocity synchronization control. This is a very simple case. In most of the synchronization application, we will use the velocity GearIn and the velocity the ratio control. That's why I will show this case in this video. Okay, let's go to the TI portal. Okay, in the previous video, I showed how can I use my template. Basically, idea is same like a standard programming. Just organize them into one huge IB. Within this IB, it has the reset, MC home, MC velocity, this style, and hot, stop, and we can output some actual speed, velocity, and position value. In the previous video, we can use the function block to control the axis. And in this video, I will use the red axis as our main axis and the blue axis as our slave axis. That's why when I create the TO for the second motor, blue motor, that time I select the synchronized access, which means this access can run as a slave, can synchronize with others. For the main access, basically, we can select the positioning access. And in some cases, your main access, your master access, can come from the encoder value or from a virtual access. The virtual access, you can directly set some value to that virtual access. For example, if we go to the configuration here, and we can select the virtual access, and then this virtual access can be just a set point value, and all other real access, the synchronized access, can synchronize with this virtual access. Or the main access can be the external encoder. For example, the encoder can be used to measure the main web travel speed, and then all other vendors can use this encoder value as the main access as a master. All other vendors can synchronize with this master access speed and velocity. Okay, as a synchronized access, other than other settings, like the same as the real access, select the drive, select the encoder. So the only difference is at here. If we double click the synchronized access configuration, and you will see the leading value interconnections. So here we can assign, so for this access, which master access it will be used. Okay, so here, if we are going to use the blue as a slave to track or synchronized with the red motor will run as a master. So here we can select the synchronization access red motor. And from here, we can select the type of the connection. So which kind of data from the master we can use? We can use the set point or the delayed. Delayed usually means if we are using some other CPUs, the access, the value. So, but basically we will use the set point, okay? And then we can go back to the program. In the OB1, I have the red motor, this big function block IB100. And the network 3, I have the blue motor control. Okay. And now if this access running as a slave to gear in with the master to synchronize with the master, basically its speed will track with the motor. If the master stop, the slave stop. If the master increase the speed acceleration, the slave will also increase together with the run master. So now we need to program the gear in. Okay. Use the network 3. So we can name this gear in. Okay, we will program the gear in. Then we go to find out the technology here. And this gear in, drag to here. And I can name that, okay, gear in. And then here we can see the master and the slave. And for this case, the master, this is the red motor. So I will drag this TO to here. Assign, this is the master. And then the slave, I will drag this synchronized access, blue motor, okay, as a slave. And this is the trigger. And we define the gear, the ratio. And once we trigger, then the slave will track with the master. Here, the ratio nominator, for example, if the red motor will run 2 times compared with the blue motor slave, means the red master, the master will run faster, 2 times faster than blue. Then the denominator, you can type in 2. So denominator, easier way we can say this is the master ratio, master. And the denominator, that's the slave ratio. Okay, so here I can name a number. For example, I can give a integer number. Keep in mind here, that's the double integer. So we can give, for example, MD12, 10. And I can name that is nominator slave. Okay, MD 10. And for here, denominator, I can use MD 14. Name, that's the denominator. That's the master. Okay, and then we can assign one trigger signal. So trigger here, we can name one. We can name that GearIn execute. Here, the acceleration, deceleration, and jerk. If we leave this default value minus the actual acceleration, deceleration that come from the slave, this acceleration, deceleration, then if we go to the configuration here, if we recall, go to the dynamic default value. Here, if we leave as a default -1, this GearIn, the acceleration, deceleration, it will use the synchronized, the slave access, 720 here. So to demonstrate this, I will temporarily leave this value as 720. This 720 is the same as the master. So temporarily, I will leave them as the same. If we go to here, temporarily, they are the same. And once we implement the synchronization, and I can decrease that acceleration and deceleration, then we will see some difference. Okay, I will temporarily leave as a default. And for this in gear, we can see the result after. Okay, now I can download the program, save and download. Okay, start. So let's reset the fault for the red motor and the blue motor. And for the drive, I can see if the drive has error or if the drive has something need to acknowledge. For this guy, I can double click and confirm the error. Acknowledge. Okay. Okay, everything is ready now. And now I'm going to start the master access first. So red motor is the master, so I'm going to use this. So let's firstly power on the motor. Okay, we also need to power on the blue motor. Okay, both motor turn on. And now I will fire this red motor using the velocity control. So velocity, MC velocity. Okay, so the MC velocity and its set point, I can set 1000. Okay, and now if I fire this motor, okay, the red motor now is running. Okay, and from here we can see the red motor now the speed is 1000 degrees per second. Okay, and we power on the blue motor, but the blue motor, we will use this blue motor to track, to synchronize with the master, the red motor. So now this motor haven't run yet. Okay, then we will use the GearIn to fire the blue motor. And from here we can see the red motor master, blue motor slave, and we haven't triggered this GearIn yet. And the ratio, we need to set the ratio. For example, firstly I will set 1/1, so we can see the two motor, the speed, they could be the same. Okay, so I will firstly set 1/1. That means master and slave, they will run the same speed. Okay, and acceleration, deceleration, here I will use the configuration from the synchronization, that dynamic value. Okay, now let's trigger this GearIn, and then meantime let's watch this in gear. Fire. We will see the blue motor start up. And then let's go back. For this blue motor, we can see its actual velocity is running 1000. Okay? And this execute command here, this is a rising edge command. So if I turn it off, actually it doesn't matter. Okay? And now if we stop the master,
even I turn off the execute command, the gear relationship is still running.
we hold the right motor, okay? We'll see both motors stop together.
That's because the slave access still geared with the master. Here, you need to be careful about this. If you accidentally fire the right motor, the blue will start.
So we need to halt this motor first, or stop the motor first. Basically, the system internally, it will disconnect the gear, okay? And now, after we halt the blue, let's fire this master again. The velocity still 1000, okay? The master velocity. And we can see now the only master is running, okay? And the B motor also stop here. Alright, so now if I change this gear ratio, this time I will let the master run faster. So the master will run 2 times faster than the slave. So that's why the denominator I set 2. Means the master will run faster than the blue, the slave motor. Okay, and now let me fire the master velocity. And we can see now the only master is running. Okay. Okay, and now let's go to the GearIn. So the GearIn now I set the ratio, a new ratio, 2/1. So let me trigger. So we can see the blue motor run 2 times slower than the master. Okay. If we turn off this, the motor, this ratio relationship is still there. Okay. If now I stop the master, okay, if I halt the master, okay, master stop, slave also stop. Okay. If now I fire this master again, and in the meantime the blue, I didn't execute the halt and the stop. Okay. So master stop, the slave stop. If the master starts again, so the slave will synchronize with the master. Okay. Unless you go to the slave and execute this halt or stop. So let's execute the halt on the blue motor. So the blue motor stop itself. So this gear relationship also disconnect. Okay. And this time let's send a new ratio. So this time I can say, let's say 8. We will run the slave run much faster than the master. Okay, the slave is the ratio is 8. The master is 2. Basically, that's the 4 times faster than master. Okay, and now let me fire this ratio. So we can see the blue run very fast. Okay. If I'm going to run a new ratio, let's say I will change this ratio back to 2, run same speed, then I will trigger. So we can see the blue run slow and synchronize the same speed with the master. Okay, if I set a lower, make this slave slower, trigger this new ratio again, we can see this blue motor slow down. Okay. Okay, now let me temporarily stop halt the master. Okay, halt the master. They stop together. Okay, I firstly disconnect, shut down the power. Okay, and now I'm going to the configuration, slave configuration, TO configuration. And now let's go to the synchronized slave TO configuration and find out this dynamic. And the 720, this is the same as the master. Now I intend to set this a slow value, let's say 120, very slow. Okay, and now download. This is used to verify if this acceleration, if this GearIn here set minus, so that acceleration deceleration actually come from this slave, that dynamic acceleration deceleration value. Okay, now let's run again. Okay, now let me set the same ratio first. Okay, and let me power on the two motors. Power on red and power on the blue. Okay, and now let's fire this red motor. Okay, still the 1000 master. Okay, we lost it. Fire. Okay, this is red, and now let me fire GearIn, and now let me GearIn the slave blue. But meantime, we will watch that blue motor. That acceleration is low, so it needs time to synchronize with the master. And meantime, we can see this in gear will turn on basically 10 seconds after. Okay, let's GearIn. Okay, we can see. Okay, we can see after 10 seconds around, so the blue motor in geared with the master.
And after it's geared, once I stop the red motor, we will see these two motors will stop together.
Hot. Okay, the stop, they are the same.
Because the blue is still geared with the master.
But if the slave try to catch the master, the acceleration is really low. It's using the acceleration from the slave. Okay, let's do that again. Especially if I set to 2000 this time. Okay, if now I fire the motor. Okay.
This time we will see after the blue geared with the master, the acceleration it will run together with the master. It won't run itself acceleration anymore because it was geared already.
If I hot the motor, we can see if they are GearIn already, so the acceleration deceleration they are the same. Okay, turn on again. Even the master side very fast. They are the same speed. Hot. Hot. So we can see they are the same. But if we stop the blue, disconnect the GearIn. Okay, let me hot the blue. Disconnect the GearIn. Okay, and let the slave to catch the master. That time we can see the slave will run the acceleration from this access configuration. Okay, let me run the master. This time the master will run its own first. Okay, master run. Okay, now let's go to the GearIn. Let the slave to catch the master. So the acceleration will run slow. This time maybe take 20 seconds to get the in gear. Okay, let's execute. Ready, go. We can see the blue motor run acceleration very slow. Okay, now in gear, that means they are synchronized together. And once it's synchronized already, without halt or stop the slave, if master stop, the slave also stop. So let's halt. Okay, they are geared. Run again. Run. Okay, once it's geared, the slave will run the exact same as the master. Okay, halt. If I'm going to use the jog the master, so we can see it's jogging the master and the slave will synchronize with master. Go reverse, so they both go reverse. Okay, if I fire a relative move, the GearIn only care the speed. So if the master run the relative move, so if I set the relative distance, let's say 5,000. Fire a relative move. So the master will run a 5,000 distance with the speed is setting, but the slave will only synchronize with the speed rather than the position. If you are going to do the positioning synchronization, you have to use the
accurate positioning synchronization control. You have to use the T CPU, technology CPU. Then you use this positioning GearIn in this instruction list. Once you select this T CPU, those instructions will highlight. Alright, that's it for today, the velocity GearIn. Thank you for watching.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.